Welcome everyone. So we are happy to be speaking with you today. So as mentioned by Sebastian, so we will be three presenters for this today webinar. So I am Ismail Nouali, the product leader of the troubleshooting manual and the aircraft fault isolation within Airbus. And I'm working on A320 family, A330 family, A340, A350 and A380 aircraft. And with me today, Mario and Victor, could you please introduce yourself?
Thank you, Ismail. My name is Mario Kelch, and I'm the second product leader for the TSM and AFI, also responsible for the A320 family, A330 family, A340, 350, and A380.
And hello everyone, so my name is Victor Lidjoa, so I am the product support leader for SHM Skywise Health Monitoring and SFP Plus Skywise Fleet Performance Plus.
Okay, so the menu of this webinar is the following. So I will start by introducing the troubleshooting manual. Then I will explain the troubleshooting manual philosophy. Afterward, Mario will introduce AirNavX troubleshooting features that are associated to the TSM troubleshooting tab and quick dispatch. And it will follow by Skywise Fleet Performance Plus presentation made by Victor. And finally, we will have some time to answer all your questions. So let's start with the introduction. The TSM acronym stands for Troubleshooting Manual. It is used for the A320 family, A330 family, A340 and A380 aircraft. It is based on ISPEC 2200 specification and it is manual oriented. On A350, we are using the acronym AFI, which stands for Aircraft Fault Isolation, and it's based on S1000D, which is data-oriented. In fact, in ISPEC 2200, we are more talking about manual, like the Aircraft Maintenance Manual, AMM, and TSM Troubleshooting Manual. And on A350, we are more talking about data module. In ISPEC 2200, we are using HTML data format for the raw data, and on A350 we are using the XML format. The TSM and the IFI are customized products, so meaning that we customize them at MSL level, and they are ICA products, instruction for continued airworthiness, meaning that we need to deliver them at aircraft delivery, but also we need to maintain and update them to reflect the flying configuration. In this presentation, for simplification, we will use the acronym TSM, whatever the program, and A320 to cover A320 family and E30 to cover E330 family. In this presentation also, we will not introduce the E220 and the E300 programs, but the most of the content of this presentation is applicable to those aircrafts. So, the purpose of the TSM is to provide coverage of all probable aircraft faults. These include faults monitored and displayed by the aircraft system. In fact, each aircraft system has its own function to detect failure called BITE function, built-in test equipment function. But also faults that are not monitored by the aircraft system, like for example, crew observation. An example of crew observation is a vibration, a noise, or an odor in cabin area, which is not monitored. The TSM covers the aircraft system failures, and the obvious failure and structural damages are not covered by the TSM. Obvious failures is when the fault is evident, so in this case there is no need for fault confirmation and there is no need for isolation. So in this case, the aircraft maintenance manual is applicable and sufficient to clear the failure. For the structural damages, they are covered by the SRM, Structural Repair Manual. The manual is broken in two sections. So we have the fault symptoms part, which is an association of warning malfunction with or without a maintenance fault message. In general, one fault symptom is leading to one troubleshooting task. And then we have the fault isolation procedure, including the task supporting data. Now let's move to the TSM philosophy. So what are the triggers of the troubleshooting manual? In fact, we have 5. So we have cockpit effects. So all effects observed and reported by the flight crew, like for example, an ECAM warning. Cabin effects. So all effects observed and reported by the cabin crew. As an example, a failure under the FAP, flight attendant panel. We have the maintenance effects, so all effects observed and reported by the maintenance crew. The maintenance faults, so all maintenance message faults reported by the onboard maintenance system on A350, A380, and reported by CFDU, CMC on A320, A330, or A340. So those maintenance messages are detected thanks to the byte function. And finally, we have the preventive maintenance. For early failure indicators reported by the Skywise predictive maintenance or digital fleet monitoring advice. In fact, the preventive maintenance team can request to perform a troubleshooting even if the failure is not triggered yet. It's for preventive, to prevent a future failure triggering. In this slide, we have an example of a troubleshooting task on the E320 family. As I said before, the first main section is the fault symptom. So by clicking in this button, you will have the list of all the fault symptoms associated to this task with their description. Then we have the task reference and the task title. And for the fault isolation procedure, we have 4 main parts. We have the possible causes section. So these paragraphs give an overview of all the potential possible causes associated to the failure. This paragraph is for information only and should not be used to perform troubleshooting and to skip the fault confirmation and the fault isolation. The order of the possible causes is not following any probability order. Then we have the fault confirmation. This paragraph is mandatory even if it's not applicable. It will allow us to prevent unjustified troubleshooting leading to a waste of time and unjustified LRU removal. LRU stands for Line Replaceable Unit. The fault shall be confirmed when possible prior to perform the troubleshooting. The fault confirmation can include byte test, operational test, functional test. As you can see in this example, we have an operational test and a byte test to confirm the failure. Then we have the fault isolation paragraph. Due to the technology limitation, in major cases, the byte function cannot isolate only one LRU at each fault. To respond to this limitation, the TSM has this mission to isolate and clear the failure from all the probable possible causes. This function enables the isolation and the correction of the aircraft malfunction. It provides the most efficient troubleshooting following several criteria that are defined within our design office, such as the probability of the failure, the time of check, the cost, and also it defines all the tests that can be used for the isolation. An isolation test, it can be, for example, a visual check, a power supply check, etc., etc. Then finally, we have the task supporting the data, which provide all complementary information in order to facilitate the troubleshooting and or to contribute to a better understanding of the system or the malfunction. For sure, the information under the task supporting data should not be redundant with the information already available under the EML, under the system description. As you can see here, we can have a flow chart, an illustration, and decision table, and we can have also other examples. In this slide, it will summarize, in fact, what I just said before. Each system has its internal byte function to detect the failure. And if we imagine the system will detect a fault that will arise, for example, an ECAM warning, it will be sent to the flight warning system. But at the same time, a maintenance message or a fault message will be sent to the onboard maintenance system on E350, E380, or to the CFDU or CMC on E320, E330, E340. This fault will be then posted under the PFR, and the maintenance team can check this fault using the MCDU, so the multipurpose control display unit, or the onboard maintenance terminal, depending to the program. On the cockpit side, the cockpit crew will then record this fault under the logbook. For sure, all the effects observed, even the non-monitored one, need also to be logged under the logbook. In this slide, I will explain a typical TSM workflow. So let's imagine during flight, we have a failure that has an operational impact on the cockpit or in the cabin area. So this fault will be recorded under the logbook, and on ground, the maintenance team will check the logbook. If the fault is confirmed, then they will check for the dispatch status under the MEL, the minimum equipment list. If the status is a go, in this case, the maintenance team can answer the logbook and dispatch the aircraft. If it is a go if, then they need to perform some maintenance action and then dispatch the aircraft. A go if action, it can be, for example, if we have a failed shuttle valve, they will need to secure this valve in closed position by manually overriding its position to close and by disconnecting its associated electrical connector. Then we have the no-go fault for which the dispatch is not allowed. Then, for this case, the maintenance team need to proceed with the troubleshooting, and also they may need to check the PFR to find the message origin of the fault. For sure, for the go and the go if faults, the airline can decide also to perform the troubleshooting and to not use the MEL permission for dispatch. And if during the troubleshooting they cannot finish it for some reasons, for example, they discover that a spare is missing, in this case, they can go back under the MEL status. But for sure, this is not applicable for the no-go fault. At the same time, this fault will be sent in real time to the MCC, so the Maintenance Control Center of the airline, for maintenance anticipation in order to avoid AUG situation. So AUG stands for aircraft on ground. For example, they can check for the spare provisioning or to check for MEL status. This fault also will be sent for the Skywise customer to the Skywise fleet performance team. This functionality will be presented later in this presentation by Victor. Now, I come to the maintenance message classification, and on E320, E330, and E340 program, we have three types of maintenance message class. We have the class 1, so all the maintenance messages that are associated with a cockpit or a cabin effect. For example, a warning or a caution that is displayed on the ECAM warning display. Then we have the class 2 message, so all the maintenance messages that are associated with the maintenance status message. So those faults are less important than the class 1. They can be left uncorrected for a period of time. They have no impact in the current and for the some next flight. Then we have the class 3 faults. So those faults have no consequence on the current and on the consequent flight. For the indication to the flight crew, so the class 1 will be seen by the flight crew, so the cockpit and the cabin crew, and the class 2 will be seen by the cockpit crew on ground at the ECAM status page after the engine are shut off. and the class 3, they are not shown to the flight crew. For the dispatch consequences, so the maintenance team, they need to refer to the email for the class 1 to check the status, a go with, or a no. For the class 2, they need to refer to the email to check the repair interval. They are go without condition. For example, they can be left uncorrected for 10 consecutive days if the repair interval is C. For the class 3, the MEL is not applicable. For the indication to the maintenance team, so the class 1 and the class 2 will be posted under the PFR. And the class 3, they can be available on request via the system report test. On aircraft, these number 1, 2, 3, they are not shown by the airline, but in our internal browser AirNavX, they are available and they can be used for the refined search. On E350, we have 4 classes. So we have the class 0. So all the maintenance messages that are not associated with any effects, they are mainly linked to some specific message or IMA message. So IMA stands for Integrated Modular Avionics. And for specific message, it's when the LRU is accused, it's unknown, or it's generic. As an example of failure, it's power supply interrupt or overpressure. Then we have the class 1, so all the maintenance messages that are associated with a cockpit effect. Cabin effects, it's when maintenance messages are associated with a cabin effect. And class 6, when they are associated to a maintenance effect. For the indication to the flight crew, only class 1 and class 3 are shown to the flight crew. For the dispatch consequences, we need to refer to the MEL to check the dispatch status for all those classes. And for the indication to the maintenance team, all those message classes are posted under the PFR. For the E380, we have the same definition for the class 0, 1, 3, and 6. But we have 2 additional classes, the class 4 and the class 5. So for the class 4, it's all the faults that have any effect in the cockpit or in the cabin, but they have a time period for correction. In fact, they are similar to the class 2, the maintenance status message that just we have seen before under the E320 family. And then we have the class 5, all the faults without operational event, neither in the cockpit nor in the cabin, nor are time limited, but when they are combined with one or several additional faults, they will lead to an operational event in the cockpit and can lead to an aircraft delay. So for the indication to the flight crew, only class 1 and class 3 are shown by the flight crew. For the dispatch consequences, we need to check the MEL for all those message classes. And for the indication to the maintenance, all those faults will be posted under the PFR. Now we will jump to the post-flight report correlation principle. In this example, we have a PFR from A320 program. The purpose of the correlation is to define the fault symptoms from the logbook entries and from the PFR by manually correlating the warning maintenance status message with the failure message in order to find the fault symptom that will be associated to a troubleshooting task. To do this correlation, we use 2 criteria. So the first one is GMT more or less 2 minutes. It can be also consolidated by the flight phase and the ATI number. So the first 2 digits of the message. As you can see here, so we have an ECAM warning air engine 1 bleed fault linked to ATI 26 bleed system at GMT 1511. This ECAM warning is associated with the maintenance message press reg V, which we have the same ATI chapter and the same GMT. So this fault will be a class 1 because we have a maintenance message associated to an ECAM warning. On the E350, E380, so the principle is similar, but the look likes is different. And also, it's more easy because the correlation is made directly by the onboard maintenance system. As I explained before, so on A350 we have four classes. We have class 1, cockpit effect, class 3, cabin effect, class 6, maintenance effect, and then class 0, so faults without no effect. If we focus on the cockpit effect, so here we have the list of all effects triggered during the flight. And by clicking on one effect, we will have the correlated items. In fact, in this case, the fault symptom is composed by this maintenance message associated to this effect. This message will be the origin of the failure, and the maintenance team, to correct this effect, they need to perform the troubleshooting that cover this fault symptom, and to find the associated troubleshooting task, the IFI, they can click on the fault code and it will open the AirNav on board. Now I give the hand to Mario in order to present the AirNavic troubleshooting features.
We will continue now with the third part of the webinar, in which I will remind you how to find the AFI and TSM manuals under the AirNavix browser. I will not go too deep into the usage of AirNavix, since we already provided dedicated webinars for the AirNavix browser. I will explain you now the two different ways to arrive to the troubleshooting manuals. Let's start with the first way via the My Library tab. First thing you have to do to fill the context field to filter the specific aircraft you are working on, and then for sure the documentation type. In this example, the TSM for the A320. Once you set the filter, the TSM with the latest revision comes into view, as you can see in the picture under point 2. Now you have the following options: to browse through the manual, to download it, or to check the previous revision. You can also see the icon of the paperclip. Once it's shown in blue, means that an advanced copy or temporary revision is attached to your current revision. The way to access the AFI for A350 is nearly similar. Again, you need to filter the correct aircraft, but you have to keep in mind that the AFI is available under the line maintenance package. Therefore, select the line maintenance package to browse through the AFI manual. As I said, this was the first possibility to access to the TSM and AFI. However, going through the manual is time-consuming and you need to know what you are looking for beforehand. But that is usually not the case. Therefore, I want to explain to you this second way to access the correct TSM and AFI task. The Troubleshooting tab under AirNavix. This tab allows you to access from the fault reported on flight the applicable fault confirmation and isolation procedures. So we can say that this digital function allows a quick and accurate access to the relevant troubleshooting procedure. It's applicable for the commercial aircraft program A320, A330, A350 and A380. It's a much faster access to the procedures compared to the manual selection of the task via the My Library function, and on top of that, you have the possibility to correlate up to 4 messages at the same time. The search can be filtered to ECOM alerts, fault messages, local effects, and crew or maintenance observations. I can also give you an outlook for the future, as we plan to correlate more messages to refine the results and to enhance the result sorting. Let's have a look now how does the Troubleshooting tab works for the AFI manual related to the A350. First, you have to filter again the correct MSN in the context field. Secondly, you can specify the fault type. By default, it's set on full search. Then you can enter the fault code, followed by the description of the fault. At the end, you can enter the source designation. The plus button is just necessary if you would like to enter correlated faults, but keep in mind that in this case the current limit is 4 events and the type remains full search. Once you filled the troubleshooting tab, as you can see in our example with default code 2796F6RX, you will see the results in the results list. By clicking on this link, you will access the referred AFI task. The behavior is for the TSM on the legacy programs exactly the same. Only a few fields differs depending the aircraft program. In this example, we choose a demo aircraft on the single aisle program. After filtering again the MSN and the type, we have to select the 6-digit ATA reference, so not a fault code like on A380 or on A350. The description and the source field are again the same, but then the class field also differs here. The plus button brings again the possibility to enter up to 4 times events at the same time. So let's have a look with the example ventilation avionics system fault with the same functionalities to select the related TSM tasks. Something I would like to highlight is the number of results listed here. In this case, 4 results. If you only type in the event with the description without further details, the result list could be long. Therefore, we advise you to always enter also correlated failures into the search fields to achieve a clear result. As you can see, the single event listed 6 results, but finally only 1 is shown after specifying the additional events. We've finished now the third part, and I will continue with part number 4. Let me present to you now a new digital function related to the TSM reset procedures called Quick Dispatch. The Quick Dispatch function was introduced in November 2020. This function offers a quick solution to access the content of the TSM on A320 family system reset guidelines and quickly display the related ground reset procedures when available. The aim is to clear the failure and safely dispatch the aircraft. This function is available for ECOM alerts, local effects, and crew ops for which the reset is allowed with restriction. In the future, we will extend Quick Dispatch function to all ECOM alerts. We also want to combine several ECOM alerts, means a multiple event search. And finally, we will study the implementation on other aircraft programs. I finished now also part number 4, and I will hand over to the last part of today. Victor, the floor is yours.
Thank you, Mario. So now let's get into Skywise Fleet Performance Plus, which is the new Airbus digital solution to monitor your fleet. Okay. So as mentioned previously by Ismail, so when your aircraft are flying, they're sending some faults, so real-time faults and warnings through ACARS, or some aircraft parameters coming from the ACMS or sent via the ADC live data stream. So all these data are coming to Skywise Fleet Performance Plus, our new solution, or also known by their predecessor Skywise Health Monitoring or Skywise Predictive Maintenance, and they're used by your maintenance control center personnel, your engineering, or your reliability people. So here, the main objective of Skywise Fleet Performance Plus is to anticipate the maintenance activity in order to optimize the turnaround time. So here, basically, Skywise Fleet Performance Plus allows you to identify the operational impact and the dispatch conditions associated to your effects. so thanks to a connection to your minimum equipment list. Then it also allows you to directly know which are the troubleshooting tasks applicable to those effects. It also provides a direct link to additional documentation like the ISI in-service information or the TFU technical follow-up that provides you with additional recommendations from Airbus Engineering, and also a specific tags to allow to identify when some events can be experienced. Then we also have a link to your maintenance information system. So meaning that we are able to link these events through Skyway's Fit Performance Plus to your technical logbook or work orders that you create. And then it will propose the predictive maintenance recommendation in case we have some alerts that are raised by the algorithm that we build on top of your parameters, and it will provide you with what to do in order to prevent the events from happening thanks to a link to the AMM, the Aircraft Maintenance Manual. So as you can see here, the technical data quality is very key and paramount for Skyway's Fit Performance Plus. So which means that in case of any issue with the technical data, it will have a direct impact on your capability to anticipate the troubleshooting and prepare the turnaround time. So now if we get into the details of Skyway Suite Performance Plus, so for those of you who are customers of our solution, so as you know, we receive your events in the cockpit, and then through the cockpit we are able to link your events, as you see here, to the minimum equipment list item. We are also proposing a specific tab for the TFMs, the TFM tasks, and as well specific tabs for the ISI and TFU article. So in detail, what it means that for each, let's say, correlated fault case that we receive, you have the applicable MEL item that you can use to dispatch the aircraft. And as you can see here, for example, in the on the slide, you also have the operational impact of those MEL items. So, for example, here, putting the aircraft under this MEL item will have an impact on the crew operation and as well on the ETOPS capability. Okay. So then with this, we also provide a direct link to the applicable TSM task. So here in this case, no need to go into your technical data browser to look for which is the TSM task that is applicable. Here you'll have a direct link to the applicable task, and clicking on it, it will open your technical data browser with this task applicable to your aircraft and the full case that you're consulting. And as I mentioned as well, so we'll also propose, when it's applicable, a TFU or ISR article that will provide you with some additional maintenance recommendation in order to, let's say, optimize your maintenance operations. So what happens sometimes in this case is that whenever we'll have, for example, here, an issue with our technical data, so we can have a TSM task missing in this case. So here, and you will have to, in this case, go into your browser to look for the applicable task. So with this background, so we performed an analysis last year in order to identify all the cases where we could have some missing TSMs, okay, in order to improve the proposal of those TSM in Skywise Fit Performance Plus. So the results of our analysis allow to, for example, on the A350, where the correlation is performed by the aircraft, so meaning that we have a direct match from the events, so the fault codes and warnings, to the TSN task. So on the A380, we allow to it allows us to identify 6% of missing TSNs. So after investigation, we found that these were mostly due to TSN database outdated compared to the latest aircraft standards available on the operators. For the A350, we found that there were 1% of missing TSM links, mostly due to missing entries in our technical data manual. Then for the A220, since here we are collecting the data from your the current flight summary or the post-flight summary where the correlation can be done is done on ground or on the aircraft. Here we have a direct link from the fault to the TSM task. Okay, so which means that here on this aircraft program, we have a direct correspondence between the faults that we received and the applicable TSNs. So for this, our analysis allowed to identify no missing TSM proposed by Skywise Fit Performance Plus. Then for our legacy aircraft, so the A320 family and the A330 family, since the correlation here is done mostly on the ground, here it allowed us to identify for the A320 19% of missing TSM. Okay, and for the A330, we identified 25% of missing TSM. So digging deeper on these cases, they were mainly due to a discrepancy between our technical data content and the data, the messages that we received from the aircraft. Okay, so mainly due to source data issues. So the let's say the events as they are listed in the TSMs were not the same as the one provided by the aircraft, and sometimes as well some configuration issues because some operators perform some changes on the aircraft and on their side that are not reported to Airbus, so not tracked in our technical data manual. Okay. So with this status, so last year we put in place a task force between Airbus technical data, Airbus engineering, and Airbus SFP Plus development teams in order to do a focus on this legacy program where we had the most missing TSMs identified. So here the objective was to improve the technical data manuals. So in case of discrepancy between the aircraft and the TSM manual, we tried to let's say correct the source that had an issue, and also input some additional information in case of missing entries. And all this work allowed us to have in the end, let's say mid of this year, up to 13% of missing TSMs for the A320. We went to 19 to 30% compared to last year. And for the A330, we went from 25% to 13% mid of this year. So here, as you can see, we did a huge improvement of our manual, TSM manual. Not that is beneficial not only for Skywise Speed Performance Plus customers, but for all customers that are using our Airbus TSM manual. And with this concludes my report on Skywise Speed Performance Plus. So now I'll turn it over to Mario for the Q&A session.
We arrived now at the end of the slides, and it's time for the Q&A. Any question is welcome, and as you have seen already in the first slide, we will send a summary afterwards. For feedback or any further questions, feel free to contact your tech data representatives as shown below in this picture. Thank you all and see you soon.